Hello everyone, welcome back to our last session on transportation model. So in this lecture we will be checking the optimality, or we will be finding the optimum solution. If you remember, in the previous lecture we have solved one numerical by Vogel's approximation method. Now we will be testing the optimality of the same numerical by modified distribution method, which is also referred as UV method. So on the screen it is visible that this particular numerical was initially solved by Vogel's approximation method. So it is already solved by Vogel's approximation method. Okay. So here you can see in this particular numerical there are 3 factories and 4 warehouses, and we have 6 allocations. So this was the first allocation. The solution of this numerical by Vogel's approximation method is already in the previous video which is uploaded. So we have got 6 allocations or 6 non-negative allocations. Okay, and at the end of the previous video we have also found out that the transportation cost for this particular numerical with the help of Vogel's approximation method was, I guess it was 779. Yes, it was 779 rupees. Now this is nothing but what? This is a basic feasible solution. Yeah, initial basic feasible solution. Now let us find the optimal solution by this method, which is modified distribution method. Okay, so now the first step of this modified distribution method is, you can write down, step number 1 is allocated cells. Whichever cells are allocated at that point, the cost Ij should be equal to Ui plus Vj. Okay, so what exactly is that? Let us understand. Now first of all, from the above matrix we will be writing down only the value where allocation is being done. So here at this point 19 the allocation was done, at 10 the allocation was done, at 40, 60, 8 and 20. So these are the cells value where allocation is done. Okay, all other values we can write down dash. Okay, now in this matrix what we need to do is we need to write down U1, U2, U3 for 3 rows, and V1, V2, V3 and V4 for 4 columns. Okay, now just identify a row or a column in which maximum allocations are done. If we see the first row 19 and 10, only 2 allocations are done. If we see the second row 40 and 60, again 2 allocations are done. If we see the third row where 8 and 20, there are 2 positions where allocation are done. Similarly, in the first column only 19, at 1 position allocation is done. In the second column also only at 1 position the allocation is done. In the third column also at 1 position the allocation is done. But in the fourth column, at all the 3 positions the allocation is done. So identify the row or column where the maximum allocation is done and write down the value of U1, U2, U3 or V1, V2, V3, V4, whatever is corresponding to that particular row or column, equate it to 0. Okay, so now here we have the fourth column has the maximum allocation. 3 positions are allocated. So corresponding to the fourth column we have value of V4, and we will write the value of V4 as 0. Okay, and now we will be calculating the value of U1, U2, U3 and V1, V2, V3. Okay, now let me tell you, according to this formula, Cij stands for cell value. So if we consider this particular cell value, so we can write down 10 is equal to U1 plus V4. Yes or no? Because U1 and V4 are the corresponding values of that particular cell. Similarly, we can write down 60 is equal to U2 plus V4. 20 is equal to U3 plus V4. So this is the meaning of this formula. Okay. So let us start. So if first of all, if 10 equals to U1 plus V4 and we know that V4 is 0, so it means that U1 will be equal to 10. Similarly, if 60 is U2 plus V4 and V4 is 0, so U2 is equal to 60. Similarly, U3 is equal to 20. Okay. Now for this cell value, we can write down 40 is equal to V3 plus 60. So V3 will be nothing but what? V3 will be minus 20. So by using this particular standard formula, let us find the value of V1, V2, V3, V4, U1, U2, U3. Okay. Similarly, for 8 cell value, 8 will be equal to this 20 plus this V2. So this V2 will be equal to minus 12. Similarly, this 19 will be equal to U1 plus V1 and U1 is 10. So V1 will be equal to 9. So we have completed the first step, which is for allocated cells. Okay. Now step number 2 will be for non-allocated cells. So second matrix will be for non-allocated cells. Now let us write down all the cell values which are not allocated. In the previous matrix we have written allocated cell values. Now we will write non-allocated. So we have 30, 50, 70, 30, 40 and 70. All other cell values we will write down dash. Okay. Now we will copy down the same values of U1, U2, U3 and V1, V2, V3, V4 from the previous matrix. So now we have U1 equals to 10, U2 equals to 60, U3 equals to 20, V1 equals to 9, V2 equals to minus 12, V3 equals to minus 20 and V4 equals to 0. And now for non-allocated cells, we can write down Cij minus Ui plus Vj should be greater than or equal to 0. Now look at this formula carefully. Cij means the cost value which is given in the matrix. So this 30, 50, 70, 80. Uij, Vj will be corresponding addition. Okay. So for example, at cell number 2, this cell number 1, 2, U1 is 10, V2 is minus 12. So 10 minus 12 will be equal to minus 2. I will write it at the top. Similarly, at cell number first row and third column 50, cell value 50, we have 10 and minus 20. So we will write here as minus 10. At this value, we will write 60 plus 9, that will be 69. At this position, we will have minus 12 plus 60, that will be equal to 48. At this position, we will write 9 plus 20 as 29. And at this position, we will write 20 minus 20 at 0. Okay. Now, the important point is Cij is this value which is written below, and Uij plus Vj is this value which is written above. So the difference between these two values should be either 0 or positive. So if we see 70 minus 69 is positive, so it is satisfying our condition. 40 minus 29 is positive, so again it is satisfying our condition. 30 minus minus 2 is positive, so this condition is also getting satisfied. 50 minus minus 10 is also positive, so this is also getting satisfied. 70 minus 0 is positive, so this is getting satisfied. But here in the cell number 22, 30 minus 48 is not positive or 0, it is negative. So the cell number 22 is not satisfying. Okay, and as cell number 22 is not satisfying, so we can write down as all Cij minus ui plus vj is not greater than or equal to 0, therefore the above solution is not optimal. So previously the numerical which we solved with the help of Vogel's approximation method gave us the solution as rupees 779. But now we have come to the conclusion that this 779 rupees is not the optimal solution. So what we did is we checked the optimality. Okay, if in this numerical all the Cij minus ui plus vj values would have been 0 or positive, so in that case we would have written that the solution that we got by Vogel's approximation method is basic feasible solution as well as it is optimal solution. Okay, but here it is not optimal, so we have already checked for optimality. Okay, so now the next step will be to find the optimal solution. Means if 779 is not the optimal solution, then what exactly is the optimal solution? Okay, so now we will start with the next method, that is the extended version of modified distribution method. So now what we do is, here let me write down some important points for you. We will write down allocate theta at cell number 22. Okay, so cell number 22, at that position we will allocate theta. Why at cell number 22? Because at cell number 22 the condition is not getting satisfied. Okay, so now again I will write down the allocated cell values. Okay, so now the allocated cell values are 19, 10, 40, 60, 8 and 20. And now I will add the cell value at cell number 22 also, which is equal to 30. Okay, now the allocations, let us check the first table. In the first table we can note down the allocations. So just a minute. Okay, so to 19 5 was allocated, to 10 2 was allocated, to 47 was allocated, to 62 was allocated, to 8 was allocated, and to 20 10 was allocated. So now what we have written is allocate theta. So we have allocated theta here at cell number 22. Now see, this is a very important step. Please focus. So now if we have allocated theta, okay, if we do the addition, this 5 plus 2 is 7, this 7 plus 2 is 9, this 8 plus 10 is 18, this is 5, 8, 7 and 14. If we see the initial numerical, this is nothing but the demand and supply it is given. Okay, so the allocations, if we add the allocations, we will get the demand and supply. But now here we have added a theta. So now this will become 9 plus theta. Okay, and as the theta is added, what we need to do is we need to form a loop. Okay, so we can go downwards here. So in this line already theta is added. So what we will do is we will subtract theta from this 8. Okay, so if we add this theta, 8 and minus theta, so what we will get 8 plus theta minus theta, so it will be nothing but 8. Okay, now if we see the third row, in this third row we have 10 plus 8 18 and we have 18 minus theta. This theta is extra, so we need to eliminate this theta, so we will add plus theta. So what we will do is we will add here 10 plus theta. Okay, so now we are going to complete the loop. From here we will go upward. Okay, so now if we add these value, 2 plus 2 4 plus 10 14, 14 plus theta, but we don't need 14 plus theta, we need only 14. So again we need to subtract 1 theta. So here we will write down 2 minus theta. Okay, and now we will go to the left. Now in this row also we have initially we have added the theta. Now in this row also we have theta plus 7 plus 2 minus theta. So again this gets cancelled out. Okay. So if we rewrite this, we have 19 where 5 is allocated, 10 where 2 is allocated, 30 where theta is allocated, 40 where 7 is allocated, 60 where 2 minus theta is allocated, 8 where 8 minus theta is allocated, and 20 where 10 plus theta is allocated. And we are getting a loop. We need to form a closed loop. Okay, there is no other method to form a closed loop. Okay, we can turn or make a 90-degree turn only if it is a allocated cell, others it's not possible. Okay, so now we have total 4 values of theta. Okay, so the 4 values of theta is theta, 2 minus theta, 8 minus theta, and we have 10 plus theta. So what we need to do is we need to identify the negative values of theta. So the negative value of theta is 2 minus theta and 8 minus theta. Okay. So what we do is we equate these both the values. We equate both the values to 0 and take minimum of them. So it means that we will take minimum of either 2 minus theta equal to 0 or 8 minus theta equal to 0. So we will take minimum of, if we solve this equation we get theta as 2, and if we solve this equation we get theta as 8. We will take minimum of both of them. So the minimum value, or that is our theta, will be equal to 2. Put this theta in this particular matrix. If we put the theta in this particular matrix, we will get a new matrix. Let me write down the matrix for you. Okay, so now we will get a final matrix. Here we have 19 and 5 is allocated, 10 and 2 is allocated, 30 where theta is allocated, theta is 2, 47 is allocated, 60, 2 minus theta means 2 minus 2 is 0, 8 minus theta is 8 minus 2 is 6, and finally 20, 10 plus theta is 12. Okay, so now if we calculate the transportation cost, the transportation cost will be 19 into 5 plus 10 into 2 plus 30 into 2 plus 40 into 7 plus 60 into 0 plus 8 into 6 plus 20 into 12. Now the transportation cost that we are getting is equal to 743. Okay, initial transportation cost by Vogel's approximation method was 779, and by modified distribution method we have minimized the transportation cost, and now the final transportation cost is 746. So this is all about the modified distribution method. Even you can calculate one more step to check whether this particular solution is optimal or not. For that, what we need to do is we need to again check for optimality. If you remember, checking the optimality consists of 2 steps. The first step is for allocated cell, Cij must be equal to Ui plus Vj. Okay? And for non-allocated cells, Cij minus into bracket Ui plus Vj should be less than or equal, should be greater than or equal to 0. If it is getting satisfied, then we can say that this solution 743 is an optimal solution. Okay. So the 5 methods, northwest corner method, row minima, column minima, least cost method, and Vogel's approximation method, all these 5 methods are the methods of finding the basic initial feasible solution, whereas the modified distribution method is the method to check whether the solution by the first 5 method is optimal or not, and if it is not optimal, this particular method gives us the optimal solution. So thank you very much. In the upcoming session, we will start with the decision theory module of operational research. Thank you.